Hello, AP Physics, and welcome to the 2021 school year. Very strange way to start the school year, just sitting at home on your computer, but here we go. Hopefully, we'll get to see each other in a couple weeks. So, what we're going to do today is we're going to all get together in a full class, and that this is going to be similar to what we're going to call our synchronous class when we're all together normally. Now, on an average day, that's going to be Mondays and Wednesdays. A group is going to be in the synchronous class. And then on Tuesdays and Thursdays, the B group is going to be on the synchronous class. So today we're going to all be together just for today. But then starting Wednesday and Thursday, we'll go into that breakout between the A and the B groups. Okay, so that's it. Let's go ahead and jump into how we're going to organize ourselves in physics and what to get started on this week. So the website, the Google Classroom, looks like this. And on the first page here, this is our stream page. I'm just going to go ahead and put our daily planner and the Zoom link for our Zoom meetings. So let's go ahead and just take a look at the daily planner to start with. So notice that the planner itself is just going to be a Google Doc that is going to be hyperlinked with a bunch of different resources that we use in class. You'll see those on the right-hand side under the documents. And then we're also going to have a lesson and a homework section, and you'll be able to see what we're doing for today, what we're doing for tomorrow. But then really for this whole entire quarter, you'll be able to see our work throughout the whole thing just by referring back to this document. So spend some time getting to know this document. The next thing we'll do then is we are going to jump into the classwork section. And in the classwork part of our class, you're going to see it's organized into weeks. And so that's the category here for this week that we're in. And then over here, we have it organized into resources. And those are things that we'll need for the AP class. So notice in the weeks, we're just going to start with our first link right here is going to be our PowerPoint, or I guess this is Google Slides, and it's going to show us what we're up to this week. And so I'm going to go ahead and design this Google presentation for 2 days. The first day is the synchronous day, which is the one that we're working on this Monday all together. And notice here it says synchronous day, and all the slides to follow are that. And then the next day, Tuesday, is going to be the asynchronous day. That's the one where you will work on your own and work with partners, be able to ask me questions by way of comments in Google Classroom. But otherwise, it's sort of a remote day, working on your own. So going back to our beginning of our slideshow, I will start slideshows just by showing what we're going to do as an overview for the synchronous versus the asynchronous days. Now, again, today we're all together, but on Wednesday, it's just going to be the A group. And then tomorrow, we're all going to be asynchronous. But then on Thursday, the B group will be doing the synchronous day. Okay, so notice it lays it all out here for you. It's also got a slide here that shows you what's going to be due this week on certain days at certain times. A little bit of work looking at our calendar here so you can see our calendar. If you guys would go ahead and get yourself a computer to bring to class with you every day. So we're going to really not be passing out papers like we have in years past. We're going to be working with a computer for the most part. We're also going to need a journal. And in physics, because this is a class where we have to do a lot of drawing things out and manipulating equations and doing a lot of solving with formulas and symbols and things like that, it's really important that we actually write on paper. And so a lot of the work we're going to do is going to be writing in our journal, giving it really good titles and numbering things well, and then taking pictures and uploading that into Google Drive. So that's a big way that we'll be working through things in class. So get yourself a journal, have yourself a computer. It's mainly what you need for class. Also, because we're going to be doing a lot of this work at home, you'll want to have some tools. And some basic tools include like a tape measure, a timer, a camera, bathroom scale, protractor, calculator. All those things will be needed for our house. So getting into the synchronous day, okay, we're going to go ahead and do a little get to know you activity to start. And so I will go ahead and just talk a little bit about myself and my family. And then I'm going to have you break out into some Zoom breakout rooms with 3 people. And those 3 people are going to be your partner for the whole week. So as soon as you get together with those 3 people, you want to find out a little bit like how can you get in contact with them? What are their links to their school accounts and stuff, so you could share things together, get their names, all that kind of stuff. But otherwise, we're going to go ahead and get to know those people through this series of 4 questions. So just a little get to know you activity, and those will be our partners for the week. Next thing, we have time goals. So I want you to focus on every day. We're going to have our 80 minutes of class. We do that 4 days a week. And then we're also going to have 30 minutes of homework on average. And then when you put all that together over the 4-day week, that works out to 440 minutes. Now, we also have Friday, which is going to be a day to sort of catch up with everything. So between those 4 days right there and Friday, I'm just asking that we put together that whole 440 minutes for the whole entire week. And I want you guys to keep track of your time to see how we're doing with our time. So something that we'll work on quite a bit is this whole idea of timing. How much time are we spending on AP Physics? Now, today we're going to go ahead and do a little lesson around measurements and order of operations with a scale, like a sense of scale. We're going to do some things related to conversions, just a bunch of math skills that we're going to be working on in physics, just to see, here's what we already know, here's how we apply it to physics. Okay, so you'll want to get your journal out for this. We'll take some notes in here. And I've got some notes here that are just some resources that you could use. So you don't have to go through these and take notes off of these, but the conversion notes here and the measurement notes right here will help you if you're having a hard time with some of the problem solving we'll do right after the notes. Okay, so some of the things that we look at in physics is when we make measurements and we write numbers down, we want to pay attention to what we're actually writing down. Okay, so for instance, if you're going to go ahead and record like you're looking at your speedometer in your car, and your car says it's going 30. Okay, so that number means something, right? And so you'd want to write down the number 30, and you want to pay a little bit of attention to like how precise that number is. What are you estimating with that number? When we write those numbers down, that's what we call the quantity, and that's how we do our math. We do our equations and stuff with those quantities. Now, we also need to record the unit that goes along with that too. So if I say I'm just going 30, it leaves a lot of uncertainty there. Are you going 30 kilometers per hour? Are you going 30 miles per hour? Those are totally different things. And so in physics, we're going to be using a variety of units, but there's a special kind of unit we call the SI unit. Okay, and the SI unit is basically this idea that there's like a standard that scientists around the world have agreed on that we can go ahead and share with. And that standard unit for length is called a meter. And for time, we call that one the second. And for mass, we call that the kilogram. And as we start physics, I want you to memorize those three right there. Length, time, and mass are in meter, second, and kilogram. So memorize those. Okay. Now, I've got a couple little side pieces in the notes here. You can go ahead and look over here, and I've got some links at the bottom. And I'm not necessarily thinking you have to take notes on these. We're not going to do this on like a test or anything, but it's just some interesting like about the history and about how do we measure these things. So each one of these has like a different video link or a podcast link in the bottom, and you can check those out and get all nerdy about it. But we've got this idea of length. We measure it in the meter, but how do we actually define the meter? There's a little video down there to help you with that. We have one with time. How do we define exactly what a second is? And there's a little link down there for a YouTube video shows how we do it. And then the other one here is the mass. Like, what do we actually say that when we say something's like a kilogram? What do we exactly mean by that? So this goes into that with a little podcast too. So once we have our 3 units down and we've memorized the idea that we've got meters, we've got seconds, we've got kilograms. Now we can take those units and we can put them together and make other units. Those original 3 that I mentioned are there. They're called fundamental units. But when you put them together, you get something called a derived unit, which is made out of these fundamental units. An example is velocity. Okay, velocity is a fancy word for speed. When you add direction to it, we call it velocity. And it's just like when you're driving in your car and you look down at the speedometer and you say, yeah, I'm going 30 miles per hour. Well, if you think about that, miles per hour, the miles part is a measure of distance and the hour part is a measure of time. Now, if you want to put that into SI units, we would say the measure of distance is meters, measure of time is seconds. So we end up with a unit called meters per second. And that's our derived unit that we use for speed or velocity. Okay, so you see the ones for acceleration, force, and energy down here too. Now I want you to notice in the speaker notes at the bottom right here, we have got all kinds of information to help you out about the meanings behind these slides. And so go ahead and read through those and see if they help you out as we work through these. Now, when you're recording numbers, here's 3 examples that I give you here for displacement, speed, and pressure. And I just show you some pictures. And I'm like, go ahead and just record what that number should be. And so when you're recording a number from physics, when you're doing science in general, you want to record the quantity of the number as well as the unit. And so I've given you some examples here to think that through. Now, one thing that we often will do in physics is To see whether or not we're dealing with an appropriate variable here, we do something called a unit analysis. And it can tell you, like, based on some physics formulas that we have, like, what are the appropriate units for that variable? And sometimes we connect it through to a formula. So I'm just going to start with a physics formula here for acceleration. So acceleration in physics, we define it as a change of velocity with respect to a change of time. Change of velocity over change of time. And the units for velocity, we call those like meters per second. Okay. And the units for time, we say per seconds. And so if you put that in the formula there, you're saying something like meters per second per second. See that? And then when you put those per seconds together, it becomes meters per second squared. And so that's sort of how we would do unit analysis and come up with units for acceleration. You'll see we do another one right below it for force too. Okay. So now that we have seen what these units are and how they relate to each other, I want you to try a problem that requires you to do some dimensional analysis. And I'll show you like a method to do that. But one thing to note is up at the top here, we've got this conversions notes, and they're going to help you to look through the process of dimensional analysis. I think some of you have probably done this before, but this is just something to get on top of right now because we'll do a lot of conversions in physics. So notice right here that there's a question that says, suppose the velocity of a car is 36 miles per hour and it travels for 4 seconds. Show that the distance traveled in that time is 64 meters. So using the formula distance equals velocity times time, if I were just to take 36 miles per hour times 4 seconds, okay, you're thinking, oh, I could just do 36 times 4. That's right. But the units for that would be miles times seconds per hour, okay, which is not a very normal unit for distance. So you want to be able to do conversions at this point. And on the next page, I've shown you like how would I set that up. So what I would do then is I would take my 36 miles per hour, and notice how I have miles in the numerator and hours in the denominator. I'd multiply it times time in the numerator. And then I would do some conversions. And the goal with the conversions is to get to the place that I want to be. In this case, I wanted to get to meters for distance. So what I would do then is I would take my miles and I would do a conversion ratio where I say 1 mile is the equivalent of 1,609 meters. And because of the miles, I can cancel the units of miles there. They're the numerator and the denominator. And 1 hour is equal to 3,600 seconds. I can cancel hours, and seconds cancel now also right here. And then I'm just left with meters, and that's where I get my answer from. Okay, so that whole process right there, we call it dimensional analysis. And this method where I use the train tracks, we sometimes call that factor label method. So that's a good way to do conversions. Okay. Moving forward, we're going to be thinking in terms of order of magnitude a lot in physics. Physics deals with really big numbers and really small numbers. And so just understanding what we mean by order of magnitude, and just think about your exponents to the power of 10 to the power of an exponent. If you have 10 to the power of 0, the order of magnitude that we refer to as the order of 0 are numbers that are in the ones column. Okay. If you have an order of magnitude to the, say, -9 up here, okay, notice that number is in the nano category right here, and it's like 0.00000001. Okay, and you can go up in the different direction. Let's say it's power of 10 to the 6. That's an order of magnitude of 6. Okay, that's in the millions right there. So just understanding what order of magnitude is, it gives us an ability to do some estimations. And here's a quick estimation, like what is the difference in order of magnitude between the mass of the universe, which is in the order of magnitude of 10 to the 50 kilograms, and how would that compare to the mass of a quark, which is a subatomic particle that makes up protons and neutrons, and it's in the order of magnitude of to the -30. Okay, so the difference between those is an order of magnitude difference of 80 orders of magnitude. So just guys to show you how broad the scope of the universe is. We've got a bunch of different values here to show what the size, what the order of size is for different things in the universe. And another quick question to sort of see, do you understand how to do these questions related to order of magnitude? Okay. All right. Now, once you're finished with those notes right there and you've kind of looked through the resources that we have in there, you will want to get back together with your partners. And this is a process that we're going to do quite a bit this year. So you want to find a way to like get together with those 3 people. Okay. So you want to be able to communicate. So you could probably have someone open up a Zoom and you could all sit in the Zoom together. You could go ahead and get on like a text chat function. But what you want to do is be able to converse with each other. And you're going to then open up this link for the measurements in physics assignment. Okay. And the link looks like this, and it's a bunch of different questions related to the notes that we just took. And then you're going to split up the work. And so in your journal, one of you might want to say, I'll do 5 and 7. Someone else will do like 8 and 9. Someone else will do 11 and 12. And as you're doing your 2 of the 6 problems, you're going to be talking to each other and be like, this is what I think this is supposed to be. Do you have any ideas? Oh, I think you did that wrong. I think you need to look up the formula for this or something like that. And so by working together, you all come to an agreement where you're like, okay, we can see we each did our 2. They look like they're right. And then you're going to want to have one of your partners open up a shared Google Doc. And then you could take a picture of your work from your journal, carefully labeled. And then you're going to go ahead and put that in the Google Doc. And then when you're finished, the Google Doc will have all 6 questions. And you'll put the 3 partners' names at the top. And then you're going to take that document and then upload it into Google Classroom for me. Now, if that process seems a little complicated at first, you'll want to get used to it because you're going to be doing a lot of it this year. So kind of getting used to collaborating with partners, working together, and then turning in a single assignment. Now, in Google Classroom, it's actually going to look like 2 people didn't turn their work in and only 1 person did. But don't worry about that. I'm only going to grade it so all 3 of you get the same grade. So. All right. The last thing you'll do today is fill out this reflection form. And the reflection form on asynchronous days counts as attendance, but I count it as like a little mini grade every day. And this is really important for me and for you. Okay. So what I do with these reflection forms is I ask different questions every day, but like what went well today? What was difficult for you? How many hours did you spend? What questions do you have? I look through those forms and I answer those questions and I modify lessons to make sure that we have an appropriate level of work for the amount of time that we have. Okay, so that is what we're doing today. That's everything for the synchronous day. Now, again, normally this would only be the A group or the B group doing the synchronous day. Today, we're both together. Next time, it'll be just one of us. And then we'll switch to the asynchronous and I'll go look at that with you guys tomorrow. So have a great day. It's a great day to be a Lakewood Tiger. Rawr.